Okay, so this is your lab for this week, right? And we have two parts, right? Two identical parts, two exercises with the same data set. The main exercise here is a researcher wants to know if smoking is related to birth weight or weight at birth, right? If when the mother smokes during pregnancy, if that has a name, if that is related with the baby's birth weight. We've already established that income has very little, right? There's very little difference in income between those babies that are born with low birth weight and those that are born at normal or high birth weight. So what we're going to do is we're going to create a contingency table to look at the averages, right? For the number of cigarettes smoked, that's that variable 6. And we're going to divide that by our grouping variable is going to be this low birth weight, right? And we're going to see if there is a difference, and then we're going to conduct a hypothesis test to see if that difference is also there in the population. We're going to state our hypothesis, determine the critical value, alpha, determine the degrees of freedom, and then conduct the test, right? Sorting the data, obtaining the p-value for equal variances, for unequal variances, and then obtain the t-statistic, and see if we can reject the norm. See if really the number of cigarettes is related to birth weight in the population. All right, so that's what we're going to do. Let's go to that data. So we're starting here. I'm going to go to first thing, go into file, and then make a copy of this. Okay. So because otherwise it's not going to let you do anything. But I'm going to stay on this data set so that you can see it here. I will leave it here, and you can see it when you're, when you click on there, you will be able to see it and see my formulas and so forth. But as you create a copy, I'm going to see you leaving this data set. Anyway, so I'm going to create this. First thing, I'm going to select the data and create that pivot table and see, right, if there is a difference. So I'm going to go to the pivot table, new sheet, and I'm going to bring to the rows this low birth weight. It's going to be my grouping variable, and then to the values, I'm going to bring this cigarettes smoked per day. And the default is this sum, but we don't care about the sum. What we want is the average, right? And for some reason, this average is giving me, okay. I'm asking for more decimal points using this one, right? So here we have that for the average number of cigarettes smoked for mothers that had babies of normal or high weight was 1.8 cigarettes a day. And the average number of cigarettes smoked for mothers that had babies with low birth weight was almost 5 cigarettes per day. Okay. And we're also going to ask for these variable cigarettes, we're going to ask for the standard deviation. Oh, in this case, they're pretty different, okay, in the sample. And we're also going to ask for the number of observations in each, although we already kind of know that, right? We know that count, we're asking for count. Okay, we know this from our previous example, that 126 babies were cataloged as low weight, and 1,262 at normal or higher. All right, so, okay, this is it. This is the N for the low, and this is the N for the high weight. And this is the difference in the averages, right? That's a pretty, it's almost what? It's 3 cigarettes per day, the difference in means, right? And the overall is 2 cigarettes per day for all moms. Again, this is the 80s. Probably if we conducted this survey now, it would be a lot lower. But anyway, let's go and start with this test. So the first thing we need to ask is, are the groups related in some way? Are they matched? Right? And the answer is no, right? We don't observe one group because we observe the other. These are independent. Babies who were born at low weight are independent of the babies that were born at normal weight. We don't, these are independent families. They don't, we don't observe one because of the other. So they're not matched. And are the variances in the population equal? They look pretty unequal, at least in the sample. But we're going to do both tests, right? So we're going to do 4 equal variances, although it doesn't seem that way, but I'm going to do it, and 4 unequal variance. Okay, and we're going to first calculate, we're going to have the N here. No, the N, not the N, but we're going to put the alpha, right, that we're using for a test, the degrees of freedom, and we're going to calculate the critical value T, and then we're going to get the p-value for the test, and then we're going to get the T statistic for the test, right? And that's all we need. All right. We are going to do both an unequal and equal variances. We've already established that. So now what we need to do is to state our null hypothesis. And the null is always that there is no difference in the average number of cigarettes smoked between low and normal weight babies. Okay? There's no difference in the average number of cigarettes smoked for the mothers, right? Not the babies. Okay. And the alternative hypothesis, of course, is that there is oh, we forgot something on this one. On this null hypothesis, we forgot to state in the population. And that's a big one, because every hypothesis is about the population. And the alternative will be that there is a difference in cigarettes smoked, right? Between babies in the population. All right, good. All right, so the next step is to determine our significance level, right? What is the probability that we're going to be wrong in rejecting that null? and we choose 0.05 at the most, right? And this is the same for any test. Now we're going to calculate the degrees of freedom. Now, what is the formula for the degrees of freedom depending on the test? Here, when it's non-paired, right? They're not matched, they're not paired. For equal variances, it's n, the n for one group plus the n for the other group minus 2, right? So the n for one group, this plus this, that's that, minus 2, 1386. So this would be 1386. Now, the degrees of freedom, assuming unequal variances, that's given by, we get n1 minus 1, you know, the n for the first group minus 1, and then the n for the second group minus 1, and we choose the smaller of those two. In this case, this one minus 1 and this one minus 1. That minus 1 is 125. That one was mine is 1261. 125 is the smaller. So we will choose that one. So it's 125 here. Good. Now, determine the critical value T for alpha, right? For those degrees of freedom. So this is given by the T inverse. And we're going to put alpha here, 0.05, comma, the degrees of freedom, 1386. And that's the same as before, right? It is always the same. It's the same n, that's the same degrees of freedom, the same alpha. So equal to T inverse, in this case, for 0.05 and 125 degrees of freedom. All right. There you go. All right. Now, we're going to calculate the p-value for the test, right? And that means that the formula there is going to ask us for all the cigarettes smoked, right? For the values of cigarettes smoked for babies that had low birth weight, and then all the cigarettes smoked for babies that had normal or high weight. So that means that we have to sort all the data set in terms of this grouping variable, like the low birth weight. And the way I'm going to do that is I select all that data set, not the whole thing because I have my tables here, just the data set, go to data, sort arrange. Remember to say that your data set, the first row is variable names. And then we're sorting by this low birth weight. That's our grouping variable. And then sort. Now all our data sets should look the same, right? Okay. Now we're ready. It's sorted. We have the number of cigarettes for those low birth weight babies, and a lot of them are 0. Let's see. So equal to T test, and this is going to ask us first for, give me the values of the test variable or right, the cigarettes for those, for the first group. Okay, there you go. And then comma, and then give me the cigarettes for those in the second group. And this is a larger group. Okay, and then comma. And the next parameter this function is asking is for how many tails do you want in your test? And we say 2. It's both sided. We don't know if if in the population it's higher or lower. And then comma, the last parameter is what kind of test? It's not a 1 because it's not paired, it's not matched. And we're assuming first of unequal variance or equal variances, I'm sorry. So that's a 2. And if we hit enter, we get a very small number. Okay. And then we're going to do the same for unequal variances, equal to t test, and get the number of cigarettes for the first group. Of course, you can also write this, right? You can right? You don't need to select this. You can also write from J128 to J1389. But I'm going to take the long road here and just select the whole thing. All right, comma, how many tails? 2, comma, what type of test? We already did the equal variances. This is the unequal variances, so it's a 3. Close parentheses, and we have the p-values. Again, the p-value is the probability that you would get a t-statistic as large as the one you did if the null was true, right? But we don't know exactly what that t-statistic we got is because Excel is keeping it in the back, behind the curtains. So we're gonna ask Excel, what was the t-value that you got, right? For using this t-inverse, we can say, hey, for that probability and these degrees of freedom, what was that t-value? It was a 5.4, right? Okay, that's pretty high. Let's do the same for this other one. So equal t inverse. So for this probability and these degrees of freedom, right? What is the t-value there? And it's a 3.53, 53. Okay, so let's interpret the p-values. There is, it's not 0, right? But it is very, very small. It's virtually 0, but it's never 0. So there is a very, very small chance that we would get a t of 5.4 if the null was true, right? That's what this p-value is telling us. Our t for this test, right, is 5.4. It's much higher than the critical value. The critical value is 1.996. And we know this critical value, there's only 5% chance that you will get this or higher. And ours is much higher. So it's a lot less than 5% chance that we would get it. And the p-value is telling us exactly the chance of that. There is a 0.0000007% chance that we will get a t-value of 5.4 if the null was true. That's assuming equal variances. If we assume unequal variances, there is a 0.05 chance, right? 0.05% chance that we will get a t of 3.54 if the null was true, right? This t value that we got is much higher than the critical value. So we can reject that null easily, right? So regardless of if it's equal or unequal variances, it doesn't really matter because we know we can reject the null easily in this case. And if we reject the null, that there is no difference, then we can accept the alternative, right? And the alternative is that there is a difference in the average number of cigarettes smoked by mothers for babies that were born at low weight and babies that were born at normal or higher weight, right? And of course, this is not news. That's why you have that message now on cigarette boxes that say smoking may cause, lung cancer or also birth defects, right? So that was expected, and it's a big difference, right? In the birth weight, and it was only about an average of 3 cigarettes per day change in average was had a pretty big impact. So anyway, this is how you would conduct a t-test. And then the rest of the lab is asking you to do the same thing, but you're going to look at mother's education, if that is related to low birth weight. All right.